Linear equations is what we have already discussed in case of polynomials in the previous session. A linear polynomial is a polynomial with degree 1, and if I have one variable, we call it as a linear polynomial in one variable. If I have two variables, then we call that as a linear polynomial in two variables. Similarly, a linear equation in two variables is an equation which is linear and consists of two variables. Say for example, I take initially with the heading linear equation in two variables. The condition here is that the equation must be linear and must consist of two variables, is what is defined as a linear equation in two variables. Say let's start with, say for example, I take 2x plus 3 equal to 0. An equation which has 2x plus 3 equal to 0 is called a linear equation because the highest power of x is 1, so it must be linear, and then it is a linear equation in one variable because I find only one unknown, which is x. Is an example of a linear equation in one variable, which is x. Is a linear equation in one variable, which is x. Similarly, if I take, say, 2x plus 3y plus 4 equal to 0, then this is called a linear equation because each of its variables have the highest powers as 1. Therefore, it must be a linear equation. But because I have two unknowns, x and y, this particular equation is called linear equation in two variables. So which differs between this and this? This is called linear equation in two variables, x and y. For example, I take x plus 3y square minus 4 equal to 0 is not a linear equation because it is linear in x, but it is not linear in y because the degree of y is 2 or the power of y is 2. So this equation is linear in x but not linear in y. Therefore, on the whole, it is not a linear equation in y because y square defines that y term is not linear. The power of y is 2. Similarly, if I take, say for example, is a linear equation because each of its powers is 1. So this is a linear equation in two variables x and y. So this is how we understand the difference between the linear equation in one variable x and linear equation in two variables x and y, is how we understand the linear equations. Now coming to the general form, how do we represent the linear equation in two variables in general form is very important of this in this topic of the session. So the general form says that a linear equation is always denoted in the form ax plus by plus c equal to 0, where a, b, c are real numbers, where a, b and c belong to R and a, b are not equal to 0, is called a linear equation in two variables x and y, is how we denote in general form. So the linear equation in two variables is ax plus by plus c equal to 0, where a, b, c are real numbers and a or b is not equal to 0. Either a or b is non-zero, is how we define the general form of a linear equation in two variables x and y. Now next the question comes on how many solutions does a linear equation have. Say for example, if I have a linear equation, I consider the power as 1. Therefore, every linear equation has only one solution. But because the linear equation here is with two variables, now the question comes, if I had a linear equation in one variable as 2x minus 4 equal to 0, then it's easy to find the solutions because immediately I can get 2x equal to 4 implies x 2 times is 2. So x is equal to 2 is the solution for a linear equation in one variable, which we obtain in this form. But how do we find the solution of the linear equations in two variables, which are the two unknowns out there, is what we are going to discuss in the continued session. Now next comes finding the solution of the linear equation in two variables. How do we find the solution of linear equation in two variables is what we're going to discuss here. So for example, let me start with the heading which says solution of linear equations in two variables x and y. Now let me take two referred examples, say x plus y plus 1 equal to 0 and x minus y plus 5 equal to 0. Now these are the two linear equations which I have here. One is x plus y plus 1 equal to 0 and x minus y plus 5 equal to 0. Now the reason why I have taken two linear equations in two variables x and y is that because each linear equation has two unknowns, we need minimum two linear equations for solving to get the solution. Getting the solution out of one linear equation in two variables is not possible because two unknowns, two conditions, three unknowns, three conditions, one unknown, one condition. So because there are two unknowns, I need two conditions out there, the condition 1 and the condition 2, which would yield finding the solution of the linear equations. Now say for example, I take these two linear equations and I wanted to find the solution, then each of them I take separately. X plus y equals minus 1 and x minus y equals minus 5. By taking all the constants to the right and all x and y terms to the left, I would like to solve using the simultaneous method. So once I just arrange all the constants on the right side and all the unknowns on the left, then I try to either add or subtract, so that on adding, we have learned about this in the lower classes. So when we add, this gets cancelled and I get x plus x is 2x minus 6. That implies my x is minus 3, which I get by solving with addition of the two equations. Now once I get the value of x, I can get the value of y either by substituting this x in this equation or this equation, depends on the choice left by you. So when I take x equal to minus 3, in one of the equation I get minus 3 plus y is equal to minus 1, which I have taken out here. This equation, which is considered here, gives me minus 3 plus y is minus 1. That implies y is minus 3 when brought to the right gets 3 minus 1, which is 2. Therefore y is equal to 2. And finally I get the solution. Therefore solution of the given linear equations is x equal to minus 3 and y equal to 2, which are the solutions of the given linear equations in two unknowns x and y, is how we solve algebraically in this method. Now, as we have already discussed that every linear equation can also be represented graphically, so let's understand graphically how we can solve the two linear equations graphically. So the graphical understanding of solution of linear equations is what is for the session.